All right, we're sharing. Hello, this is Kyle Van Hook, and I'm here to show off the final project for GPE104 game programming. All right, so earlier, I, well, first, I do have a document. This is the game, this is the Google game document that I basically used to plan the entire game from what I was going to add, what I was going to keep kind of on the sidelines, but just get done, like before each loop in the dictionary. I've already made an itch.io and uploaded it. I've made a board screen and uploaded the game there. The GitHub is public, but I'll show you those later. I need to get this out of the way so I can show you. But if I actually show you the basic project, I'd like to show you the code first. So starting off with if else clause. When I was doing the if and else statement, I was planning on modifying one of the damage on player spawn, damage on overlap. There's also another one for damage on collision, but the idea was to make it a bit more defined. We have basically we're basically checking if the collided object has a health component, and we're checking to make sure that that's not null. And we're then at this point here, like around at least this section here, we're checking to see if the insta-kill boolean that we have right here is true or not. If it is true, we're going to go here, check get the death component, check that that's not false or not null, and then we're just going to kill it. Otherwise, we're just going to get the health component and do the take damage function in the player health component. This is going to be annoying because it's going to be in the way, but this is the damage on overlap. Damage on collision is pretty much the exact same. So that's an if-else statement with an else clause. We've got a couple of abstract methods, or well, actually, I only really have one, and that is the pawn and the controller. The basic pawn and controller classes are public abstract classes. The controller just has the make decisions method and just has place for a pawn. The pawn has basically storing for all of the components it's going to have: health, death component, rigid body, a sprite renderer, and then it has what variables for move speed, max speed, and the jump force. Those were ones I at least knew I was going to need originally, and then has three methods: move right, move left, and jump. And then here we have the actual player pawn, which is a child of the pawn class. And this is the player controller, which is a child of the controller class. There are a couple other classes that aren't, but probably. Oh, also, I should also mention others. Also, the death component and health component are also abstract classes. The death component just has a abstract class a method die, and the health component just has the max health and current health as variables, and then it has a take damage function, a function to check if it is alive for a Boolean method, a heal method, and a die method. And then for the player health, component just has everything in there. We also, since we're we have at least one sound for the player when they're getting hurt. We have an audio clip from AudioManager instance. The hurt sound. We're checking to make sure that this currently spawned object has current health, which is the max health. We're going to the UI manager and getting the current health and the max health on update to make sure, and this is going to UI that is going to be going on the on our screen overlay canvas UI. We have the take damage function. It plays an audio source when it takes damage. It subtracts the current health from the amount of damage taken. It checks if it's still alive with this current health, and if it is not alive, we then set the current health to 0. We also get the current health and the max health from here and send it to the UI manager, and then we go through the die function. Is alive is just a bool function to check if the current health is greater than 0. If it is, it's true. If it's not, it's false. Heal function is current health equals current health plus amount, and we're just adding to that, and we're checking if the current health is larger than the max health. We're just going to set the current health to max health so it doesn't overheal. And for the health function, or player health function, for die, we're just checking that the player actually has a death component. And then if we do, if they do have a death component, we're just going to go to the death component and do die. Now, for the death destroy, there's a couple of these. There's death destroy here, which is this is basically just get an object, destroy it immediately. I think there's player death, where it's basically the same as death destroy. We just have this section here where we're de-incrementing from the player lives in the game manager. Do I have any more that I can show off? We have enemy destroy, which is again the same. Well, but instead it's the same as death destroy, but instead of de-incrementing lives, we're just incrementing the score amount in the game manager. And this also has the score amount in the death component. I don't think I didn't make add score a child class to collect coin or collect gem, but those are all the abstract classes and their children classes with methods, and that can be overridden by the child class. So one for loop. I did do a for loop somewhere. I know where the for each loop is. Oh, I know where the for loop is. It's for loop spawn. All right. So in the for loop spawn, I've made a button, and so we have a game object, which is the spawn object that we're going to be spawning. We have the spawn point. We have the spawn count, how many objects we want to spawn. We have a bool to check if the button is pressed. We have a sprite renderer, which is our sprite renderer. We have the new sprite that we're going to be replacing the old sprite with. And then we have an audio switch, a audio switch clip for basically like a little click or a button. So in the start, we're getting the sprite renderer. We're making sure that the button is pressed is false. And for the switch clip, we're just getting the audio clip from the audio manager. And on a trigger event, we're going to check if the collision object is a player, and then we're going to go to spawn objects. So if B is button pressed is false, we are going to get the we're going to make a vector from the spawn point position, and then as long as I for loop here, as long as I is going to start at 0, and as long as I is less than spawn count, we're going to do this incrementally. So we're just going to instantiate a spawn object at the spawn position with a regular rotation. But every time we're going to kind of move the spawn position after the object has been spawned, like 1 in the X position, just so we have a row, a row of objects that are being spawned. After this for loop has been done I number of times, we're going to set B button pressed equal to true. Then we're going to get our sprite renderer, dot sprite, and then we're going to set the sprite to our new sprite. In this case, it's just a sprite of the button being pressed down. And then we're going to play an audio clip at point, which is the switch clip. And while I'm here, I'd like to at least show you that, just so I can show it quickly, and also that I don't have to go searching for it too far for the game, or before the editing of this video. Anyways, this is just the game, and I'm pretty sure I set audio in the recording, so you should be able to hear the music, the sound effects, the boing. But alright, here we go. So this is our little switch. It has the switch, the for loop switch. If I just pass it and hit the trigger box, we do spawn 5 objects, and they're floating coins. And just to show you, thing is in the way, but we do have the for loop spawn, and it's spawning coins. It has a spawn position, which is this, which is a child object of the spawn of the button for loop. We're just going to be spawn 5. We already get the sprite renderer inside the game. We get a tile. We've already got the tile sprite set, and we also already get the switch clip in the object. All right. That is for loop. For each loop, actually, this is going to be for each and for the dictionary, because I really didn't have a reason to use them at all, or at least not for this project. So I just made something to show that I know how to use them, and this is for the for each dictionary. It is a combination of a for each loop and a dictionary. So starting with, we have a dictionary object here that has a string and an int, and this is people's age, people's ages, and it takes a string and an int. We have a public bool, play loop, just to check that it's playing. And then at the start, we are going to add to the dictionary 5 names. We got Tom, he's 50. We got Mary, he's 38. She's 38. Bob's 42. Chris is 16. And Jack is 21. We set the play loop to true. In the update, we check if play loop is true. We go to print ages. And then print ages is the for each loop here, where we are getting the key value pair string. So for in people, for each of the string int in age, in people's age, we are going to print in the debug log age.key, which is the string, and then ages plus age.value, which is the integer. And then we'll just go through the whole dictionary, and then we'll set the play loop to false. That is, I put that object immediately somewhere. For each dictionary, yeah, for each dictionary. It's right here. It's just it immediately starts here. And as you can see, this is fine. It starts at start. It prints out Tom is age 50, Mary is age 38, Bob is age 42, Chris's age is 16, Jack's age is 21, And that's pretty much all of them. So I know how to use dictionaries. I know how to set them out. And the last one for basic coding is a list, in which case we need to go to level 2. All right, there's 3 codes I have to show you. One is oh yeah, lock key list, destroy key, and destroy lock. So I think probably probably destroy key is the best one to show off first, because this is one of the key objects that's important. Actually, no. Let's just show the list for the list object, list code first. So we make this a public instance, public static instance, and we make a list called key list. We're checking to make sure that the instance equals null. If it is, we're going to make this instance this one, and if not, we're going to destroy the game object it's attached to. And in awake, we are making a new key list, or a new key list of destroy key objects. In which case, in the object, the list or whatever that is in the level, in this case it's going to be level 2, is going to print out how many keys are in the level. In this case, it should be 2. But now, going to key list or destroy key, we have a public audio clip, but that's really the only thing we need. We are at the start of the level going to add this to the lock keylist.instance.keylist, add this. We're going to load the key clip sound from the audio manager. And then on destroy, it has a So on destroy, we're going to remove this this object from the list, the key list, and on a trigger, we're going to check that the player object has the tag player, or the colliding object has the tag player. We're going to play a ClipAtPoint audio source and just play the collection sound. Then we're going to destroy this game object. So that will that's the object. Any object has a destroy key object is the object we're going to be keeping an eye on, and their keys obviously. But then the final one that we need to look at to see this kind of system that works is just destroy lock. And any object that has this code is that we are checking if the lock keylist.instance.keylist.count equals 0, then we're going to destroy this game object. And level 2 of the game. The exit of the level is right here, but it's locked behind 2 locks. So we need to run around the level and search for the keys. And one is over here. And the other is across this lake on a small island with little spiky guys that will kill us if we step or touch them. But I probably should have shown the list, but now that both of those objects are dead, both of the key objects are dead. If we go down the list, at one point we collect the key object in the level, and that is then 1. Then we go down, and then we get the second key, and that's destroyed. I didn't make a debug log to say that the locks are being destroyed, but the code is working. All right, and that's the basic coding. User interface. All right. What's the best one I can probably show? Probably level 1. All right. Actually, no. UI canvas. All right. So zooming out, we have a basic UI canvas. To the left, no alarm. To the left, we have a text box that shows the lives text. It is right now. It's just a text box. We have score text the same. We have a health bar, which is a slider, which it's just a modified slider made to be a little bit short, to not have the handle and to be full at start. But we also have another text for health text value. But all of this works in the UI manager code, which is right here. Yeah, UI manager. And we're basically getting a couple things. We have public text for the score text, for the lives text, and also for the health text. We have int for the current score and int for the current player lives. And this is fine because we don't really want these to be modified outside the player. We want these to be modified by the by the game manager, by the game manager again because of the score, and also by the player health component, where some of these things are coming from. But we are taking the health text and the bar slide and placing them into those slots in the UI manager so that they're child objects now. And in this case, we want to be able to make sure that this is also an instance so that I can go from scene to scene following the player. So there's only one instance of it. And we've also made sure that it has a game object don't destroy and load. For at least for the start, we are checking that score.text is set to score and score lives.text is set to lives. Then we are getting for the current player lives from the game manager, the player lives from the current score. For the current score, we're getting also from the game manager the score. And then constantly we are updating update health, update score text, and update lives count. That's just junk text. So for update health, we are getting the health bar slider dot value, and we're making it equal to current health. And we're doing the same for the health bar slider max value and making it set to the player health component's max health. And then we're just setting the health.text to the current health string, current health / max health. For the update score, we're again getting the current score from the game instance score, and we're then just setting the score.text to score plus score, and then the current score. And update lives is more or less the same. Did I need? This is basically, yeah, pretty much all that needs to be shown. I can show off that they are working. So, the coins, if I collect an object, the score will increase. If I run into an enemy that won't kill me, like these pill bugs, let me actually wait until he's on the floor so I don't stomp on him. If I collide with him, I will take damage. And if I jump onto an insta-kill object, my lives have gone from 3 to 2, 2 to 1, and we're dead. Good, actually. Let's do this first. Let's show that the health also works. Oof. Oof. Okay, yeah, that works. All right. All right. World Space Canvas. I have a couple instances of World Space Canvas in two levels, this one and another one. In this case, we're just using I didn't really want to make a instruction screen, but I thought it would be interesting to basically just make a very short introductory tutorial and tell them what the player of the keys are. And since there's only 3, I just have to do move right, move left, and then jump, and place the keys. But I think this is at least decent as a player tutorial. I've informed them that they can jump on these enemies. And that's basically it for this one. For level 2, the only other world space object... Actually, this world text canvas, just to show you that these objects are, yes, they are world text, world space. The canvas that these and this one are in is considered is made to world space. Where are you? Yeah, texting that one. This one's also world space. Level 3 does not have world space text in it. But yeah, we've got world space text. And then you need to show one of each following types. UI types, a text box, an image, and a button. So I've already shown that these are the score and the lives are text boxes. So are the world space objects here. They're text boxes as well. If I go to like the menu scene, just start from here. We have a buttons here. If I click on them, they'll take them to their respective scenes. This is credits. I can click the menu. It'll go here. It'll go back to the menu here. If I press start, it'll start. And if I go to exit, it'll exit out of the game. And the same can also be said for the win-lose screens. So I got buttons. I've got, well, technically, I am using an image. Yeah, like this background is just a blue image square. But I think the better example would be the title screen. Where are you? Start screen. Yeah, crash landing. That's just text. But the actual image behind it is a sprite image that I made. And that's just another image to image. Xbox image button. Yeah, all right. So that stuff's done. All right. Background music. PlayOneShot and PlayClipAtPoint. I've got a couple instances. So I guess for the PlayerPawn, let's go to the jump. To the jump. There we are. So this is the jump function, the PlayerPawn, and I'll show you the PlayerPawn and PlayerController properly later. But we're checking if the PlayerPawn is grounded. We do a debug log is jumping, and then if once we're jumping, we get to the player audio source and we do PlayOneShot jump clip, which is just a jumping sound that the player makes. And then we're adding force to the player body to make them jump upwards. There, one. Actually, select coin. The coins and the prefabs. Coins, where are you? There you are. Coins. The coins do have a collect coin script. And this is important because this basically just has the score amount for the coin and an audio clip for a coin collection sound. And basically on trigger, if the collided object does not equal null. Oh, and has a player pawn. We're going to play a clip at point. That is the coin clip. There's a couple options to do this. It's the coin, the gem, coin, gem, the bugs you can squish on. I think the spring jump box is another. Now they're a PlayClipAtPoint. They should probably do a play clip. There should probably be a play clip at PlayOneShot, but that won't ruin the game. And then finally, there's background music. I have a small object here that has background music, and it's basically just playing a looped ditty sound. Where's the audio? It's background music. This one. You can probably, I don't know if you can hear it, but hopefully you can. But you'll hear it once we actually play. And it's playing that constantly. So if I press W, you can hear the spring sound. The coins make like clinking sounds. The enemies, if you jump on top of them, make squish sounds. The springs make boing sounds. Actually, I would like to at least show the gem sounds, because that's different than the coin sounds. They make like a shining sound. And that is all the audio. This is already half an hour long. Wow. All right. So for the game manager, I have a game manager. It keeps track of the scores. It keeps track of the player lives. It also keeps track of resetting lives. We're getting the player transform, or the layer end level transform. We're getting the player, keeping track of the player pawn. We're making sure that this is the only instance here. At the start, we're going to reset the lives to player equals lives. We're keeping constantly in the update. We're checking if the player lives are always less. If the player lives are less than or equal to 0. If this ever becomes true, then we go to the lose function, and in which case, that means we've lost the game, and we're going to check if the score is greater than the player prefab's get float high score. If that's true, we're going to set the player prefab's high score to the score. Then we're going to reset player lives to the reset lives, which should basically, at the start of the game, be 3 or whatever someone has set as the player lives. We're going to reset the score to 0. Then we're going to load the lose scene in the win condition, which is, I need to show the win condition, which is touching an object, but I'll show the object in a minute. If we're basically going to do the same thing again. We're going to check if score player preps high score. If it's true, we're going to set the high score, reset the lives, and reset the score. Go to next level. No, that's not it, I think. Is it? No. Objects, prefabs. The big one. No, that's just the win game script, which is somewhere looking in the face. There it is. And the win game script it's attached to an object, and all you got to do is touch the trigger. And it's as long as the collided object has the player tag player, and there's also a pawn. I'm double checking to make sure that this is correct. We're gonna set the game manager. Well, we're gonna run the game manager .instance win. That's gonna reset everything and just get all the information. And then we're gonna go to the win screen. Let's see. I'm just gonna try and go through this quickly because now this is half an hour. We got controller, pawn abstract classes. We've got, let's do the player controller first. This one has also been set to an instance to make sure that the player controller keeps moving through the levels with the player pawn that it's attached to. We're going to check to make sure that this is the only instance of it. And then in the update, we have the make decisions function. And the make decisions function is where we have all the object code, or the controls. So for like GetKey, we're checking if the GetKey, if the key is held down. Like for D, then we're going to do the pawn move right. And if the key is released, we're going to check if actually we can't do pawn. We can't just do the pawn from the from the controller abstract. Because the pawn and the player pawn objects are too different and don't have all the things in them that we want to do. So we're going to transform, or at least convert, and make a temporary pawn, in which case we're then going to go into the drag linear velocity x function. And this is just to help the to show that or at least help the player kind of slow down when they're running. Otherwise, they're very slippery. We have similar code for a code key A, where we're checking if it's held, A is held down, then I'll move left, and if key is up, A is up. We're going to do the same thing, but for dragging the velocity x. And then for GetKeyDown for W, I don't really want to double jump, but I also want to make sure that they jump at least once until they're grounded again. So we just set that for the pawn jump. Get button and get key. Yeah. I could also do this for the input. But going to player pawn, I can show you this properly. We have to make the player pawn. We only want one, so we're making this another static instance. This is all variables for like box casting, raycast. This is the audio stuff, player audio source, and the jump clip. This is the animator for the player animation, or the little animation that he does have. I'll talk about this once the actual once the actual function comes up. But again, just checking to make sure this is the only player instance. Making sure this doesn't destroy on load. Loading the jump clip. We're loading all the health comps from everything. Junk code, but moving right. So for the this is also the player pawn is also where we have one of the forces, or at least moving an object with forces attached. So for moving right, we're checking if the player has the rigid body. We're checking if the rigid body's linear velocity is greater than the max speed, which I think, yeah, it's in pawn. I think I actually added that when I was making this. But if that's true, if rigid body is true and is less than max speed, we're going to set the animator comp to bool to is running, and that's just going to set the animation to start running. We're going to flip the sprite x true. That way they go from looking left to looking right, and thankfully that works with the animator comp, at least for sprites. So that's awesome. And then for the rigid body, we're going to add force, transform right, times move speed, with a force mode 2D impulse. And we don't have to worry about time.delta time for force, because that's already in the force automatically. Left is pretty much the same, except we're making sure that well, actually, no. So if we're checking if the rigid body times the linear velocity x is greater than max speed times -1. And this makes sense because if they're going left, then they're going into a negative direction. actually. Oh, well, it's already done. But we're going to set the animator to running. We're going to make the sprite renderer flip X false, so it flips back to looking left. And then we're going to get rigid body, add force. And we're going to add force to the left by the move speed and do force mode 2D dot impulse. As for jumping, all right, so for jump, I kind of already did. So speed run for jump. We're going to check if the grounded method is true. If it's true, we're going to play an audio source or play PlayerOneShot jump clip. Then we're going to add force to the rigid body, transform up by the jump force. But yeah, we got a couple things we need to check. So the bool method is grounded. So if physics.boxcast, and we're now setting making a box raycast to detect if the player is off the ground. We're getting the vector origin, we're getting the vector size, the float angle, the vector direction. In this case, we want the direction to go down. The cast distance, and then the ground into ground layer. Oh yeah, that's the layer mask. We're basically checking if this is true, then if it's true, then we're basically grounded, we're touching the ground. If it's false, we are not, then we're jumping, or probably off the ground at least. Private void on draw gizmos. This is basically just a way, this is just to allow us to actually see the box cast not in the game, but in the editor. So we're basically drawing a wire cube with the transform position and the transform up times the cast distance and the original box size. Oh yeah, and the drag linear velocity. This is just to we're just multiplying the linear velocity by the drag amount. And then we're setting the bool animator comp set bool is running to false. So their running animation stops and they just do the idle animation. And I think just to show the player animator hurt sound, that's already in. Yeah, we're just checking if we hit the ground layer which is pretty much on any object or like any ground object. And that's PlayerPawn and PlayerController. So for single purpose principle, a lot of the methods, or yeah, like the code blocks, they only really do one thing. Like if I want to code to destroy a key, well, if I wanted to just destroy something, I just do death destroy because that would destroy it. But say I want to play a specific sound, then I'd make sure. Well, actually, collect coin and collect gem could have been one script, and I could just change the sound. Well, actually, well, no, because I'm getting the coin clip from the audio manager just to save time. But the idea of a single purpose code is just that every section of code or like every script here does one thing or one related thing. Like death destroy will just destroy the object. Adding score is a say something collides with it. You're going to get the game instance manager and add score and then destroy this object. It's one thing that's one and done. It doesn't mix and match into other codes too much. It's very similar to like a game to game instance managers? No, like singleton patterns. But in this case, you're wanting to try and avoid using a lot of singletons, and just if you need to get something from another from an object, you're checking the collision and stuff, and then getting the object, or like getting a pawn or some code from that object. But everything else does one thing, or takes control over one section of the game. Like the menu controller. This is solely for the purpose of all the of like button presses. If in like any button that has this is pressed, or like on start click, we'll just start the game. Any on menu click will just takes us to the menu. It doesn't do anything else. That's the whole idea of single purpose. And if you need to make something that does something similar, but you just need to be modified, you can make a child object that does the exact same thing, but that one thing added. All right, abstraction, encapsulation, inheritance, and polymorphism. So for like polymorphism means many things. We can have objects that are similar, like all. I didn't make an all enemy class, but let's say we have a class that has just enemies. Every object that has this class is considered an enemy. But maybe we want to get more specific and say, oh, this is a jumping enemy, or this is a spiked enemy. Then those are two separate things. They aren't affected by any. Well, actually, they all have the enemy code, but they don't have each other's code. So anything that is in the jumping classes, jumping enemies code, it can have, the parent can't grab, and neither can the other object, and vice versa for the spiked enemy. And likewise, inheritance is well, basically the same. Basically, the child and the superclass and the subclass. Like with the player controller and the player pawns, and their parent classes, the controller and the pawns. Like the player controller will have access to the make decisions function, and it can do whatever it wants with it. Add or make anything. But if I was to make another function in the player controller, the controller abstract class would not be able to get that function, because it does not inherit the controller, or it does not control that method in the controller class. But the player controller inherits everything in the controller class. Well, actually, the pawn is probably a better object, because player pawn inherits everything here, but the pawn doesn't get any other extra extra methods, like is grounded or anything for like array casting. Where am I? I'm trying to keep track. Encapsulation. Encapsulation is trying to keep things private between various methods. Basically, you're Oh, this is not good for me, because I don't remember and I don't want to remake this. But for encapsulation, you don't allow objects that aren't related to other objects to actually, no. You don't allow users to get access to important information in an object. Like Maybe there's a line of code for like a health value or a score value that has to do with like counting upwards, and you don't want the player to touch that. You make that code or variable private, so the player can't touch it. If they want to touch it, they have to use like a getter or a setter method to either get that value or set that value to a different object or to a different value. And I think abstraction, it's an easy answer, but I don't remember. Abstraction is, I think, making it simple. No, I don't remember abstraction. I'm sorry. Saying, well, nothing. All right. Pretty much a good chunk of the code, or pretty much everything, all the variables are public, and they can be changed in either in the child class or in the class itself on the sidebar. Well, commented, that's fine. I'll let you go over that. One piece of data changes every frame, such as frame draw, such as movement, damage over time, etc., and must be frame rate independent. Okay, well, technically forces and the player movement works with that because that's technically frame rate independent. But I'd rather go to the movement here and show you vectors because that's probably a better way. So here in this section we have a moving floating enemy. It's a very simple enemy. It's an insta kill enemy, basically like a spiked ball from Mario. It doesn't even need a death destroy, but I added it. But the one thing that makes it interesting is the vector move character script. And this basically moves this object with vectors in a square or a rectangle, depending on the variables and speed that's been set. So going to that vector move character. All right. So we have a variable for move speed. We have floats for the timers, and those are in quotes because actually no, they aren't in quotes because they are timers. We have the track counter, which is a private int. This one don't want to be changed. And then we have a private float for timer. We are setting at the start the track counter to 1. We're setting at the start the timer to up and down timer amount. And through this, we're going through a bunch of if statements. So 1 is going to be going on the right x-axis. So if track counter does not equal 1, we're going to de-increment the timer by time dot delta time. And then we're going to change the transform position plus equals transform right times the move speed times delta time. We're basically changing the vector position of the object to the right. And we're making sure this is frame rate independent via time dot delta time with move speed. If timer is less than or equal to 0, then we're going to increment the track counter, and then we're going to reset the timer by setting it to the left and right side timer. And then going down to 2, if track counter equals 2, we're going to de-increment the timer. Then we're going to be setting the transform position up, so it'll go up. And then once timer is less than or equal to 0, we're going to increment the counter to 3, and then we're going to set the timer to equal up and down timer amount. And then de-incrementing timer, we're going to make that object move left via the vector transform position. Once the timer is 0, we're going to increment it again to 4. Then we're going to reset the timer. Once track count is 4, we're going to de-increment time. We're going to make the transform position go down, because now we're in a downward square. And then we're checking if the timer is 0. We're then going to reset the track counter back to 1. So we've done a full rotation at this point. We're going to set the timer back to up and down timer amount. And then it's basically just going to continue doing this either rectangle or square movement as long as the game's playing. Alright, and you're not important, but our character here is moving via the vector position, and he's just moving in a rectangular position. And he's pretty much doing that constantly as long as the game's running. Like, I don't know how to stop it, but that's a good example. Player input. I think I've already shown player input. I've already shown GetKey here for left and right. Jump uses GetKeyDown. This is mostly just for editing. Movement. We've done that. Collision. I've got a lot of collision. I've got ground that has box colliders. I've got like box colliders here. Actually, I learned recently that you can increase the size of blocks. So instead of having to do like, well, let me show you, like multiple blocks here, because this is stupid, and you can instead, holy crap, you can tile it. So it's one big land object that has just an increased hitbox. I felt stupid when I realized that. I even found that out first with the tiles, or the spikes that I was having issues with. But I have ground that has hitboxes. I have like key locks that have hitboxes. These have hitboxes, but these are just background images. The moving object or platform is a platform that has a hitbox. Well, if you go into the actual platform, this actually has a hitbox. The falling platforms have a hitbox. There's a lot of hitboxes. Oh yeah. And for the most part, the reason they're colliders instead of just triggers is because we want the player to connect with them and be able to touch them and jump on them. And then I think a good case to just show the in the object case of this object being a trigger, I can go to actually prefabs. Let me just open up. So the base enemy has a box collider, but it's just a trigger. I don't really care if the player well, I do care if the player collides with it. I don't care if they aren't stopped by movement, but I just care that we register that they are touched. So this square collider here for the main enemy is the base collider, is the base trigger, and we're using that just to be able to tell when the player collides, and then do damage to the player. For this smaller hitbox here is to check whenever the player is not grounded, they're falling, and if the player connects with this trigger, then they're basically stomping on the enemy. And we have a stompable enemy overlap. That's just checking. Actually, I can show you. That's better because I can stomp component. Yeah, stompable. Bubble enemy. I changed his name sometime, but I don't know when I changed that in those two, but the whole idea is that we're checking the trigger, we're checking that the colliding object is a player, has the tag player. We are getting the player pawn, we're getting the player to the body. We're checking if the player pawn is not grounded, and if the players to the rigid body linear velocity is less than 0, which means they're going down into the y value is going down into the negatives, which means they're falling. Just double checking. Then for the enemy damage overlap equals overlap. We're then getting the enemy's enemy damage overlap. We're setting this to 0 because I don't want the player to get hurt at this point because they've killed the enemy. We're then going to get a death comp for the game object this is attached to. We're going to play a clip at point, which is the squish clip, and then we're just going to kill the object this is attached to. That's how this stomp enemy overlap works. To basically make a Goomba stomp. Collision. Must add force to move. Our player is being moved by add force to it. We also have a player pawn. We have a function for when they stop moving that they're going to get more drag added to them. Via their linear velocity. And one of the best, other than jumping, I think the best, where is the scene? Scene 1. So other than jumping, which also uses physics because the player is jumping and has gravity, we also have the falling blocks. And we also have the spring, which basically just adds force to the character and makes them jump up. But once we give context to the block, it'll start a sort of timer, which will then change its static body to a dynamic rigid body, which will then activate gravity. I don't want canvas. I want falling platform script. Just to show a little bit. Where are you? Falling platform. Basically, going through here, we're getting the game object, rigid body, reading the start location, and for the transform, for the vector, and for the rigid body, we're checking if we're making a bool if it's falling. And then we have a fall time, and respawn time floats. We're checking, instead of trigger, we're checking on collision if this object is not falling and the colliding object has the tag of player, then we're going to start coroutine fall. And coroutine is an enumerator, and this is a small method that we want to run next to the object. We're setting b is falling equals true. So now we're falling. Actually, no, we're not falling. Well, technically falling, but we're then doing another function in the enumerator, which is a yield function, which makes it wait for a bit until the wait for seconds, which suspends this coroutine execution for how many fall float amounts, the fall wait variable, how many seconds that is. Then once this is done, we will continue this coroutine where we will set the rigid body type to dynamic as the now the rigid body to set the dynamic. It's now going to actually fall. And then we're going to do another yield wait for a second for respawn weight, once this is done, we're then going to set the rigid body to static. So now it doesn't have gravity, and it's just going to sit in place. We set B to is falling as false, and then we reset this game object start location. Basically, respawning it. And that's gravity. And that's a couple of objects that use gravity. I have a completed build. And for the final project build, we have a build here. You can play. We have a vector art made by me, the title screen. You can press enter on the numpad, and it will take you to main menu. We have a main menu that has a credits button. The pixel art assets come from Kenny and L. Sounds come from Pixabay. And the title screen and the end screen were made by me. We can go to the menu. We can exit from the menu. We can exit from the credits. We can start the game. And I'm just going to try and quickly finish this, just so I can show you the start screen works. We have a flag that takes the next scene. All right, good. We'll get the key. That's one key down. Now we need to get the other one over here. And then we'll go to the next level. And then this is the third level. We do have player respawning, and that works, but well, you've seen it a couple times if you've watched certain parts. I did not mean to do that. I meant to run and jump. You know, at this point, I might as well just show you that the death animation works. I regret having more than one level, but that was an aspect I wanted for the game. Okay, yay, we made it. All right, we have a final level that has, for this build, it has a high score that keeps track of the player's high score. We can press reset, and that will reset that to 0. We can do play again, and it will take us to the menu, and we can press start. We can exit out of this. We'll start the game again. I don't know, get like 20, and then we'll die. And as you can see, we're at the game over screen. We have a player high score is 20, so that changes, or at least is changed from each. It's what is it I'm trying to say? Persistent data. It's a persistent score. Let's get 10, and then let's just die so we can show that it doesn't get overwritten. Yeah, we had 10 10 points from one coin, and we still have 20 points from the score. That's great. We have game over screens, turn to main menu, quit to desktop. We have persistent data. All right. We're almost done. Thank you for sticking around for an hour-long video. This is annoying but all right. For shipping it, we have. So first of all, this is the GitHub. It's public. You can look at it. It's fully updated. Second, this is the itch.io page. You can download a zip file for the build. And then this is the boards project. It's been added to the boards page for myself. Also, objectives. I should probably add. I technically already have it under one of the game projects, so that's fine. And I think that's everything. I've gone through everything. The game shipped. It's public. You can look at the GitHub. But that's it. Thank you for sticking around for an hour. This has been a very good class. I've enjoyed it. Anyways, have a good time. Have a good day. And thank you.